Morning to those joining us from Hawaii, and good afternoon to everyone on the mainland. Welcome to the Expeditionary Energy Challenge Pitch Event, brought to you by the National Security Innovation Network in partnership with the 15th Space Surveillance Squadron. My name is Angela Austin, and I am the Challenge Program Manager at NSIN, our National Security Innovation Network. We are nested within Defense Innovation Unit, and our mission is to drive national security innovation by fostering collaboration among academia, entrepreneurs, ventures, and the DoD. Today, we're gathered to identify expeditionary energy capabilities for a mobile space domain awareness platform. The finalists presenting here today are competing for $75,000 in awards. I'd like to introduce you to Mr. Chong, Executive Director at 15th Space Surveillance Squadron. Mr. Chong, the floor is yours.
Thank you, and welcome participants. We're really looking forward to hearing your pitches. We're standing by and very interested in what you are all bringing to the table, and we'll see what happens. Thank you.
Thank you, Mr. Chong. Next, we have a message from Stephen representing the On-Ramp Hub.
Hi, thank you, Angela. My name's Steve Brennan. I'm the Managing Director here at Pacific Impact Zone. We run the Defense Innovation On-Ramp Hub, which is a program of NSIN. We're super excited here. We run the Defense Innovation On-Ramp Hub here in Hawaii, and we are super excited to be working with our partners, the Space Surveillance Squadron here in Hawaii, and bringing innovators into our AOR. There are 5 defense innovation on-ramp hubs in Arizona, Kansas, Ohio, Washington, and Hawaii. Of course, as you all know, Hawaii is the best. And our mission here is to extend aloha to innovators who want to get engaged with all of the defense activities that are going on in Hawaii, whether it's working with Indo-PACOM or any of the service branches here. So to get in contact with us, the email address is info@pacimpactzone.com. And I'm going to give you a phone number, 808-341-4702. Some of the services we can provide are consulting and connecting to COCOMs and to the PEOs. We also host events throughout the year and would love to get you on our newsletter. Congratulations to all the finalists here, and good luck. Back to you, Angela.
Thank you, Steve, for your welcome. Now we're going to kick off the pitch presentation. So each company will have 5 minutes of presentation time, followed directly by 5 minutes of Q&A, where the judging panel will ask questions. And following the Q&A, we'll have a 2 minutes of deliberation time for our judges to complete their scoring for the companies who are presenting today. Our first presenter is Foldisher, so I would like to go ahead and let them begin their presentation.
Greetings to everyone. I'm Alexander Gendel, and the company I founded is called Foldisher. This is our first time we entered an NSIT challenge, and we're really excited to be here. What we specialize in are super compact folding redeployable designs. Our goal is to innovate in this area and already have several US and foreign patents on novel mechanisms. Coming from the New York area, where most people are in a bit of a space crunch, has proven useful to generating ideas in this field. For the past 15 years, we have been developing folding mechanisms that are robust when deployed and super compact when stowed. And as some of you might know already, we did start out by making foldable furniture. Our idea for this NSIN challenge we call ARCOS, which stands for Autonomous Redeployable Compact Observatory System. And what you see on the image is our concept for a 50 kilowatt lunar solar array that we're developing as part of a NASA SBIR Phase 2 project. The array is approximately 175 square meters, elevated 30 feet above the lunar surface, and the whole system deploys or retracts seamlessly into a package of 1.9 cubic meters. Our intention is to use the basis of this design for the ARCOS power supply. After analyzing the problem statement, we realized that we could provide super compact portable power that could fit the requirements. But after the feedback from the Ask Me Anything session, we realized that we could go a step further and address the deployability of the entire observatory system. And that is how ARCOS was conceived, an autonomous, redeployable, compact observatory system that folds flat to be easily transported to any location. What ARCOS features is remote operation, ease of deployment. It uses our proprietary folding technology, is fully self-efficient, and it's extremely compact when stowed. If we receive support for the project, we could use our patented technology and know how to develop the ARCOS system. Now, power to the ARCOS is provided by two Sunflake XL pyramid hinge arrays, similar in mechanical design to the arrays we are developing for the lunar surface. Also, the proprietary UCTT deployable legs are used to provide rigid support and perfectly level the observatory structure. We think the electronic equipment can be housed in an easily accessible, secure enclosure located underneath the telescope platform. The dome design idea shown here is based on our deployable pyramid hinge system. We design and build unique deployable mechanical systems that nobody else does. And we integrate batteries, power supplies, or solar panels of other manufacturers. We looked at different state-of-the-art commercial components for the project. Several are listed here, and we are open to working with others. We looked at the EG4 solar power systems, Dell server racks, plane wave telescopes, among others. We also looked at Astrohaven, Ash Dome, and other dome designs, and realized there was really nothing very portable out there. Based on our Sunflake XL, the NASA SBIR, we started developing a system called Sunflake Terrestrial. It has a similar mechanism to the lunar array, but it's designed for horizontal rather than vertical deployment. It is supported on 3 UCTT legs and can be tilted to achieve the optimum angle towards the sun. One of our concepts is to use the solar power to feed the large batteries of electric vehicles. One Rivian has the capacity of 141 kilowatts. Any electric truck has the capacity to easily transport the array, assist in deployment, and store energy that can be used during the night. I have to say, before the Ask Me session, we were considering proposing a variation of this design to provide power and backup. But I think with ARCOS, we pushed the limits a bit further by integrating the whole solution into an easy-to-deploy system. Pyramid hinge array geometry with linear expanding structural members yields a compact, lightweight solution for providing solar and space and for terrestrial applications. By combining our novel geometries and structures with other technologies, we can provide robust, compact, redeployable power systems. I hope this presentation sheds some light on how our mechanisms can help create unique deployable structures for other applications. Thank you.
Thank you. Now let's turn it over to our judges to kick off the Q&A.
Hi, this is John here. Thank you for the presentation. My first question, since we're talking about now integrating the dome and telescope into the along with the solar power system, is how do you, or what is your approach to decoupling wind and other vibration sources from the telescope itself? Over.
So our understanding is that the telescope has to be on a super firm mounted platform, so no vibrations at all are allowable. And we think that the combination of the very rigid leg assemblies plus the weight of the batteries and the equipment that we put underneath it could provide that stable support. Obviously, more analysis and structural design is necessary, but as a concept, we do think strongly that it's viable.
Thank you.
Any other questions from our judges?
This is Richard Chong. I think it's a brilliant design. I know you started in furniture, you said, but from this origami perspective, what is durability, do you think? As far as how long do you think?
This is actually very interesting, and I sort of avoid using the word origami. I love it on one hand because it kind of shows the movement, but origami people associate with things that are flexible and flimsy, and everything that we design and aim to design is super rigid and solid. Going from the furniture, which has to be stable and supportive to the projects we're doing for NASA. It's not. I almost want to call it rock origami. It's not your typical. We're looking for a good marketing name, but yeah, it's rigid. It's definitely rigid and solid. But the good thing is you can get really compact structures with it, and it all goes down to mechanisms that we've been developing and patenting for the past 15 years.
No, thank you. That
Thanks.
question, that was of interest as far as rigidity. Good.
Yeah, no, we understand that with the telescope array. My father was into astronomy. It needs to be very. No vibrations at all are permissible.
Hi, this is Charles. Thanks for the presentation. Just had a quick question about the actual deployment mechanism. So about how long does it take for the panels to extend and retract? Is it like on the order of minutes?
It's on the order of minutes. With the system we're developing for NASA, it's not really a question of time. So we want to make the mechanism as light as possible. So we're using smaller motors. But if it needs to be deployed more quickly, you just need more powerful motors that will deploy it faster. It's on the order between seconds and minutes. But the whole idea behind Arcos is that everything is integrated so that you can bring this to a location and deploy it within minutes, or if it requires some sort of additional structure support, maybe hours, but it's meant for portability.
Thank you.
Hi, this is Sean again. Do you have an estimate of the overall system mass?
We don't right now because it actually what's going to determine the system, the mass, is the quantity of batteries that's needed, and we don't feel we have. With the solar panels, we definitely have enough power to charge a large array of batteries that will be necessary to provide stability for the system as well. But whatever the design would be, I think would be dictated by whatever vehicle would be used to transport it. If it's designed to be transported on the back of the truck, our limit would be what that truck could load and what would be easy to be moved around. So a few 100 pounds possible.
Thank you, Alexander. We appreciate your presentation. Time is up now for the Q&A. Thanks so much for being here. We are going to go into the 2 minutes of deliberation now. Next up, we have HNU Photonics.
Aloha from Maui, Hawaii. We're excited to introduce you to high battery mobile solutions. We've been developing, deploying battery solutions for 18 years, everything from utility scale to residential, everything in between. Next slide. Today we'll be focusing on our military and our mobile solutions. In this slide, we feature 3 of our successful deployments. The top one is a 150 kilowatt hour high mobile energy storage system, where we deployed it for the Army for field printable silicon carbide ceramic body armor. The second example is a 1/4 megawatt-hour hive that we developed in a precast vault and delivered to Joint Base Pearl Harbor Hickam for the Pearl microgrid. It powers a F-22 maintenance hangar for emergency power support. And then the third example is a very innovative 6T universal battery that we delivered for the Army, where we can rapidly switch between 24 and 48 volt configurations. Next slide. We've developed applications for mil-spec ruggedized deployments, meeting specification mil standard H10H, featuring weatherized connections for extreme environments. And then our hives are very customizable and adaptable for various equipment interfaces. I'll turn it over next to David Kim.
So the Hive energy storage system is a modular architecture. The system is comprised of an energy module, a power conversion module, and an energy management unit. The battery modules of that architecture come in various form factors and capacities. This modular approach allows for a highly configurable and stackable system that can be tailored to each project based on changing mission requirements. Next slide, please. The energy modules then feed these power conversion modules, which is responsible for converting the DC bus voltage to a usable regulated output voltage. The modules come in various voltages and power outputs. This includes AC single phase, 3-phase, and regulated DC voltages. And the stackable nature of the modules allows for a configurable system that is able to be designed specifically for mission load demands. Next slide, please. The modular system has an option to be mounted on a trailerized system, and that trailer system allows for rapid mobilization and quick field deployments. And the trailer option also allows for an integrated fold-out photovoltaic system, has benefits of a rapidly deployable PV system while maintaining a higher operating wind rating. And this design bridges the gap between a rigid permanent structure and a temporary fold-out system. Let me turn over to CEO Dan O'Connell.
Hive has been developing innovative battery solutions for the past 18 years. And the approach we take is similar to how an electric car uses regenerative braking. So rather than dumping that energy into heat and it's lost, it's converted to electricity and charges back to the battery. We take a similar approach. In a battery management system, we really have an energy management system where we're recycling the energy that is typically lost in a battery management system. When the cells are being balanced, what is typically done is energy is passed through a resistor and given off as heat, and it's lost. And how we do it is we recycle that energy so you maintain the full capacity of the battery. Next slide, please. We're very familiar with the Air Force remote telescope operations. We're familiar with the loads, the load profile. We feel the Hive modular solution really meets the needs. If you were to add capacity loads over time, if you were to add more computing power and you add more batteries, the new batteries are going to be limited to the capacity of the older batteries. But however, the way we recycle that energy, we can extract the maximum energy performance out of the batteries. Thank you.
Now over to our judges.
Hi, this is Sean. Thank you very much for your for the briefing here. We definitely appreciate your building to mill standards. I'm wondering what you might have been able to accomplish in terms of airworthiness. What kinds of certifications you might have for that? Over.
Could you clarify the airworthiness?
Yeah, transportability on say military aircraft like a C-17 or something like that.
Oh, I see. We have transported individual cells to complete packs We've transported them across continents, so the transportability is not an issue, if that's the question.
Okay, thank you.
I can add something real quick though. I mean, no matter how you deal with it, lithium batteries are going to be a hazardous material. But you know, it's not outside of the realm to transport them. You know, there's standards, there's capacity limitations, and then there's you know, there's safety requirements. You know, a part of the architecture, having the system being able to be disconnected down at the battery level, so that the system is off, or transporting at a lower capacity. So making sure that the battery isn't charged more than, let's say, 30%, I think is the standard. I think it puts some people at ease for transporting. And so that's kind of what's, I think the standard is keeping the capacity down and making sure that it's, the standards of how it's built is of a good quality.
Okay, thank you.
Hi, this is Dick Chong. How long do you think it takes to set up and configure for operations?
So I'll say that for power, if you had a trailerized system that rolled out to a field and you needed to power something, I mean, it's literally flipping on a switch and plugging a cable from the trailer to let's say like a spider box or something else that's distributing power, let's say within a small building or a dome or something like that. So it's literally just draping a cable from one point to the other. And you know, depending on you know, how long term of a solution is would determine, you know, like how well you would fortify that installation, right? So you know, the trailer would be propped in a way where, you know, it's stable. But if you're looking for like a long-term thing, then you would look at how to route those cables in a certain way that it would be, you know, a little bit safer on site and whatnot. But the actual, to get the power going, it's flip on the switch and plug in a cable. It's literally it.
Thank you.
Hi, this is Charles. Thanks for the presentation. I know in your presentation you mentioned a lot about solar. Is this also compatible with other charging, either directly from a grid or through a generator or something else?
Yes. Yes. So and depending on the application, so it just needs to be kind of upfront of, okay, so on site we will have a 3-phase 60 hertz 480 volt generator on site, and that's what we're using to charge to. You know, those are just some of the things that need to kind of be you know, contemplated when choosing the modules that go into the system. But yes, it can accommodate charging directly from the grid or from any type of generator.
Right.
We're at 30 seconds, so if you don't have any further questions, judges, we can go ahead and wrap this.
Nothing further from Sean.
Nothing further from me. Thank you, HNU.
Sounds
Here as
good.
well. Thank you.
Yeah, thank you guys.
Thank you, Dan. Thank you, Dan and team. We're so happy you were here today to present. We are going to allow our judges some time to deliberate, and we'll meet back with our next finalist. And now we'll hear from Helical Solar.
Hello, everyone. I'm James McKinnon, CEO and founder of Helical Solar, and today I'm here to talk to you about our Expeditionary Solar Microgrid. Next. So traditional fuel generators for expeditionary power come with a host of challenges, first and foremost being the fully burdened cost of fuel, especially for the DoD in the Iraq and Afghanistan conflicts. That ranged about $15 to $42 a gallon. There's also issues with refueling logistics, recurring maintenance, and those are all in addition to soldier and equipment casualties. Next. So our expeditionary solar microgrid has been designed to solve these challenges. We have a 5.8 kilowatt articulating dual axis array, which is equivalent to an 8.67 kilowatt rooftop system. The key to that is that it generates about 35 kilowatt hours per day in electrical energy, or about 13 megawatt hours per year, which is typically enough to generate to offset the typical U.S. single-family home. And we compare that with a dense modular microgrid with three-phase 208 or three-phase 480 and up to 52 kilowatts of power. And that is also coupled with between 10 and 368 kilowatts of lithium iron phosphate battery storage. We can also add an optional fuel cell backup that's fueled with either propane or future hydrogen, and that can extend operations in dark and cold, extreme cold weather scenarios. Next. So this is our TRL-7 prototype demo that we took down to Tyndall Air Force Base this past February. We drove at 800 miles from Texas, set it up the next morning within an hour, and we're powering an Eagle Eye load bank, as well as our Alaska Defense Shelter's Environmental Control Unit, or ECU, for some hot and cold soak testing. We were also able to demonstrate grid and 30 kilowatt diesel generator plug and play interoperability, as well as fast charging our batteries while letting the power forward through to the load itself. Next. So for our proposed Raven SDA platform for the Space Force, it's the same 10 utility grade bifacial panels for that 5.8 kilowatt array. They can generate 35 kilowatts or more in areas across the world, such as Maui, Diego Garcia, and Guam, as we simulated with PV watts. It also will have 120 mile an hour wind and 10,000 pounds snow load capability that we've already done finite element analysis with. It also will be designed for mil standard 810H tropical compatibility with its equipment enclosure, and we will use forced air cooling and dehumidification. It should be about 42 dBA of external noise when the fans are running, and it will have 34.6 kilowatts of nominal power with a 69.2 kilowatt peak running 208 volts 3-phase. And we'll be able to add in Class L and NEMA receptacles for user requirements. Next. So with adding up to 368 kilowatts hours of distributed BMS to that, it will be push button start and shut down and enable safe to touch and maintain 48 volts DC system components. And 80% of that usable capacity, which is around 294 kilowatt hours, would result in about 11 3/4 days of reserve at 25 kilowatt hours per day for the SDA platform nightly usage. We would pair that with a 300 volt DC highly conditioned supply from Magna Power, the TDS 300, and run that off of the 208 volt 3-phase, and that would provide low ripple and superior line regulation. Next. So we're a dual use company. We're currently working on a $1 billion USDA agrivoltaics project to build out this summer, and we look to disrupt both the military and commercial fuel mobile generator markets. Next. So we have about $2.43 billion in pre-seed funding so far from the US DOE Phase 1 and 2 SBIRs, as well as a USDA agrivoltaics subaward. Thank you, and I appreciate your time.
We'll now go into our judge questions. Please go ahead, judges.
Hi, thanks very much for the presentation. Sean here with a question, and you may have touched on it, and I missed it. How are these generators or solar power packs transported to the sites typically? What does the travel configuration look like? Over.
So the easiest way is just on any standard 20-foot utility trailer. We use a Lamar trailer. There are several other different brands, but any just 20-foot flatbed can transport it to a site. And then once it gets to the site, we actually have 4-point loads that we can either lift it off with, and then we'll also plan for like stakes for a 10,000-pound military forklift compatible. So you can just lift it off and place it on the ground as well.
Thanks. And a quick follow-up to that. Have you ever shipped or flown it? And when I say shipped, I mean right on a boat over water.
Not on a boat, but we drove it the 800 miles behind a F-150 down to Tenda Air Force Base. Was about a 14-hour drive, but it's built to be anchored down. We have different weld hook points and stuff to keep the vibration and motions down. I mean, we ran across a lot of bumpy stuff going across I-10 all the way to Florida, but it's designed to be rugged and take a lot of abuse.
Hi, this is Dick Chong. Thank you again. Yes, you said so after the 800-mile drive, it also handles high wind and with snow weight, I guess, resistant. And after what you just discussed with Mr. Bauman regarding the ruggedized version, but that's predicated on implanting and tie downs and everything. What about in an austere system with minimal manning, I guess you can say?
So the system that we have today, what we're proposing is integrating that higher powered microgrid and battery system in it. As far as an austere system, our goal is single man setup, and within an hour. What we took down to Tyndall was a 2-man setup within an hour. There's some enhancements we could do on that, but once it's unfolded, the articulating array unfolds, and you go through basically initialization sequence, point it towards south, and let it goes through its motions. It's set and forget. After that, it's 5-year maintenance intervals with grease zerks and a real-time clock. Basically refresh just by hooking up to it is all we anticipate.
Thank you.
Hey, this is Charles. Thanks for the presentation. So a question that I have is about the weather, how it tolerates different weather conditions. So since it's set up and it's meant to be left deployed, how much testing have you done with just evaluating how it might perform under different wind or rain or snow? I know you talked about that a little bit, but if you could elaborate on that more, that'd be great.
So under our phase 2, Department of Energy, they wanted a third-party analysis on the structural. And so we had that done with SolidWorks, and then we did our own analysis with Creo and ANSYS. And both of those, we were able to enhance the structured stuff to where we could support the 10,000 pounds of snow load and exceed 120-mile-an-hour winds. And we also modeled that while it was on the trailer with the skids and also on the ground with the skids in the prone position. And so we haven't had any full-scale wind tunnel testing to date. That would be sort of another level of development and funding to go and perform that. But it's something that we're confident that we can meet.
Great, thank you.
Thank you. We are at time, so we're going to go ahead and allow for the judges to have some time to deliberate, and we will meet back shortly with our next presenter.
Thank you, guys.
Now presenting, we have Pavilion.
Hi, my name is Colin Toohey, and I'm the co-founder and CEO of Pavilion, a Brooklyn-based company with a mission to make clean energy available in any setting. Today, we're here to talk about our solar-powered integrated structures, or SPIS, and their energy storage systems. These SPIS systems are not only solar-powered, but they provide high-density expeditionary energy and optional shelter. To give some context and background, Pavilion is a specialist in the integration of solar cells and fabrics with power systems. This ranges for us from clothing and backpacks to amphitheaters and stadiums. On the bottom right, you can see SPIS powering Coldplay's World Tour, which has been deployed and moved about 100 times in 12 months. We developed and manufactured products for New York Public Library, Texas A&M, Google, Target, the City of New York, Carnegie Hall, and more. Pavilion systems enable autonomy, flexibility, and resilience for our end users in austere environments. The kits are modular and scalable and are designed to integrate directly with existing military equipment, for example, telescopes, legacy gensets, tents, ECUs, etc. The energy storage systems are also agnostic, utilizing multiple battery cell technologies from LFP to NCM to aluminum air. End users at the 15th Space Surveillance Squadron can also use this clean energy system as a standalone or as an inline UPS system. Here, we aim to provide the 15th Space Surveillance Squadron end users with SPIS power systems, highly conditioned, high-density power for their expeditionary network of space domain awareness telescopes. Our SPIS can offer anywhere from 1 to over 100 kilowatt hours of energy storage and are broken down to 75-pound one-man carry modules. They can accommodate a minimum of 12 hours of operations before refueling or recharging is necessary, but most of our government customers utilize SPIS 24/7 without any refueling. We've been working with the U.S. Air Force since 2019 when we were awarded our first phase 1 and 2 contracts, where we were partnering with the RSO out of Wright-Patt. These energy storage systems have been deployed in dozens of exercises in real-world environments, from Guam to Alaska to Kiev to Peru. And our technology won the Air Force-wide Spark Tank competition as Project Arcwater and has been selected and funded for PACAF-wide innovation competitions in 2023 and 2024 as R2JP, including Tesseract's Ether Sprint competition. We have a number of phase 3 awards as well, and are looking to scale the technology across all AORs, including Indo-PACOM, as we make it a key tool in the agile fight throughout the DoD. The systems are completely silent, minimizing acoustic footprint, 100%. They're delivered in highly durable cases and able to withstand extreme environments and terrain within the Indo-Pacific region, which exceed MIL standard 810H and tropical conditions. They're easily stacked and connected and are fully modular, so they can be tailored to the end user's weight and power requirements. They offer integration with DC, AC, AC, DC, DC to DC, so pretty much anything you want. That includes custom voltage outputs and inputs for power nation, ground support equipment, and comms equipment. We can go anywhere in the world, hot or cold, as you saw, and they can be set up in a matter of minutes to give users immediate power without the need for fuel resupply. Our solution for this project offers highly conditioned, high-density expeditionary power, which is perfect for your network of space domain awareness telescopes. As previously mentioned, we can offer over 100 kilowatt hours of energy storage and accommodate 24 hours of operation before refueling is necessary. The systems are intelligent, so they can self-diagnose issues and provide warnings. They can be stored and pre-positioned in ISO or ISU 90 containers for long periods of time, or out in the open without the need for camouflage cover. They're silent during operations and have the capability to be covered with camouflage coatings to further reduce IR and visible signature. The SPIS systems proposed for this Expeditionary Energy Challenge can also include shelter, lighting, and high-efficiency environmental control units. Here are some of our recommended configurations, and throughout this project, we'll work with the end users to determine which version of SPIS is the best fit. For this application, we'd recommend, and we believe that something close to the Pavilion ground mount or trailer mount 30K kit is necessary. And our proposal, which can absolutely be tailored to your needs, is to deliver and test SPIS within the 15th Space Surveillance Squadron in multiple deployed locations throughout the next 6 to 18 months. This will give enough context and feedback to your high-level decision makers and determine how best to incorporate SPS's high density power with any US Space Force and Air Force network of telescopes. So thank you for your time, and we look forward to working with you all.
And now over to our judges.
Hi, this is Dick Chong. You said essentially your system is battery agnostic, and as far as conditioning is concerned, how do you plan on? I mean, what is your power conditioning system? I guess you can say. You're on mute.
Typically, we use LFP cells that are certified for air cargo, UN 3481. So that would be our main technology. Would be pre-packaged LFP systems already ready to go. The reason we say agnostic in particular here is that if weight is the driver, we have alternative technologies that we would integrate into the power system. So, and the DC AC AC DC 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 conversion is all pre-packaged in those kits, but battery agnostic in the sense that we can go lighter weight and we can work with other technologies if that were the driver.
Thank you.
Hi, this is Sean. Thanks for the presentation, and definitely appreciate the detail and the work you've been doing with the government and the places you've deployed with this. What I didn't catch was what kind of setup time there might be depending on the size of the system that you're deploying. Could you give us a sense of the length of time it takes to set some of them up on the smaller end and on the bigger end? Over.
Yeah, so on the smaller end power systems, energy storage systems, less than 60 seconds. So you're going to plug in just like you would plug anything else in. You don't need to turn on a generator and refuel. So that's going to be the power energy storage side. On the solar kits, a very simple system would take 1 to 5 minutes to pop out of the side. So pretty easy deployment. Some of the larger systems that are included in a fob, it might take more like 15 to 45 minutes where you're actually setting up a tent, you're setting up an ECU, you're setting up a whole fob. So it's not exactly pre-packaged. There are multiple components to that. So under an hour on the high end, on the low end, a minute.
Thank you.
Yes, sir.
Have any other questions from the judges? Helen, anything you want to share in more detail?
Well, I think I'm definitely interested in some of the other solutions, and it was really good to see other folks as well. And I think the overlap with some of the commercial industries here is very relevant. So we're happy to tailor what we do to meet your needs. If there's anything that comes up, we're happy to convert our systems and work with other partners too who might be on the line.
Thank you. Judges, I just want to ask one more time, do you have any further questions?
Nothing further from Sean.
There's one last one. You indicated it was 75-pound one-man carry modules. Was that right?
Yeah, correct.
Okay.
So we can, so that's stackable modular, and then we can go bigger than that if necessary.
Gotcha. Thank you.
All right, well, if that's it, we're going to go ahead and go into a 10-minute break. We'll meet back in 10 minutes at 4:06, and we'll have our next company presenting then. Thank you. Welcome back, everyone. Our next presenter is Jewel Case.
Hey there, my name is Justin Levrier, and I'm presenting on behalf of Jewel Case for the Expeditionary Energy Challenge. And I will go ahead and begin here. what we're talking about is the Jewel Case e-power system. And this is a modular, flexible, mobile, ruggedized system that is perfectly sized, where you can perfectly size it through modular nodes to create continuous power anywhere from 3 kilowatts up to 1.2 megawatts. So perfectly situated for that 25 kilowatts of continuous prime power for this brief. Energy storage wise, we can go from 5 kilowatt hours to 8 megawatt hours. So a big range there. We build the perfect power system. The idea is to distribute the right size system where you need it in field. And we can go anywhere from 48 volts up to 1,000 volts DC, and you can go AC on 120, 240, 208 three-phase, 480 AC. So what's great about this is it allows you to have ultimate flexibility, and not only, speaking of flexibility, flexible charge inputs. So you can use AC grid, AC genset. We can also use various sources of DC from solar, wind, hydro, or even other Jewel Case battery-based systems. What does this mean for us? What we're trying to do here is we have a system that is built to protect expensive equipment, not just the expensive equipment you're operating, such as sensors, but also the men and women who have to operate those machines. If they go down, that takes time. So what we're doing here is we're actually giving it a maintenance-free operation. No more dirty power. This is a pure sine wave with less than 1% ripple. So great for sensitive precision electronics, and definitely great for something like an electro-optical sensor or telescopes, such as was presented to us in this brief. And of course, bottom line there, it's also clean in terms of sustainability, little bonus. What's cool about this is it allows you to, because it's a battery-based system, the Jewel Case system is battery-based, it allows you to operate indoors and on the move. So without noise, without heat, or without vibration. This is perfect for sensors, perfect for putting in a vehicle, truck mounted, trailer mounted, and very much different than your traditional combustion sources. As we do this, when we say rugged, what does rugged mean? We meet the MIL standard of 80, I think it's 810H, and which of course is for the tropical conditions. And this is actually being currently, we're part of and participating in the OUSD R&E Task Force Radar for TREX 24-2 coming up here pretty soon. So the Jewel Case solution is a modular mobile solution that I mentioned. It's a silent power platform. Essentially on the top right, what you see, there's a truck mounted version. On the bottom right, what you're looking at is a trailer mounted version. So you can combine each of these modules in parallel and series to create the perfect size system. So they're kind of like, think of them like Lego blocks. And we're energy source agnostic. So we, what that means is chemistry agnostic. So as technology changes as far as what the best battery source is, we change with those times. For a sense of size, the Jewel e-Power system can be quite small. So for instance, top left, you'll see the inverter system. That's only, it goes in 6.5 kilowatt chunks. The bottom is your energy storage. Those go in 8.8 kilowatt hour chunks, and weight-wise are manageable by a single individual. You won't be able to see all this, but what you have is ultimate configurability to meet the end user needs. If somebody wants to see this, I'm happy to share it. This is just a small sample of possible configurations for the end user. And below, you'll see images of the types of diesel generators that we are currently replacing today in the field. One of our customers is Kennedy Space Center. You'll see a bit of a write-up here on this. We power their screens at launch and also at the Kennedy Visitor Center. And that's our CTO, Dave DeMuro, who was Apple's former head of battery, sitting in the trailer in that top right photo. Bottom left is our founder and myself at NASA during install. What you'll look at here is these are our larger systems. So we have a Zeus and Atlas. These are not drawn to scale, but what they are is swappable energy modules where you have power and energy separate from each other. And these are our larger ones that go anywhere from about 60 kilowatts in power up to the megawatt scale, or in the energy side around 170 kilowatt hours on up, which gives you continuous prime power for those longer durations, 24 hours or more. This is perfect for those type of situations. Next, what you see here, this is a bit of a case study. We actually worked with the Department of Defense through Big Safari and SAF-AQ for the Frankensam project. We developed a rapid prototype and put this to field. It's currently overseas in theater as we speak. This isn't just a theory. We're actually doing this across the U.S. This is our commercial U.S. market penetration. So you'll see that we are coast to coast and growing rapidly at that. I'll end it with just a few pieces here. On the slide, I can't talk about each of us, but we have history in this, a deep history in batteries and energy and power based on who we have here. Also, our advisors come from a pretty deep background, both from military, energy, and other areas as well. And I'm going to leave you on this last page here. I think we're right at our 5 minutes. This is kind of the highlights of what we've talked about. Love to talk about more of this here at the end. Thank you.
Now let's turn it over to the judges for our Q&A session.
Hi, this is Dick Chong. Thanks for the presentation. I might have missed this, but what would be your proposed approach for, I guess, energy production in this situation?
Yeah, thanks, Mr. Chong. As far as energy production, we're open to anything there. So we have the ability to take anything as far as a charge input. So that could be any DC source or AC source. So potentially partnering with one of the other panelists or really anything that's available. The idea is to be able to take anything that's in at hand at the moment. So if you had diesel genset, if you had solar, if you had hydro, if you have wind, whatever that ability is that you have at the time, we're able to take that in as energy and then disperse it out as it's needed.
Thank you.
Hi, this is Charles. Thanks for the presentation. I had a quick question about the transportability. I know you've built to various military standards, but have you ever transported your systems via aircraft or transported over different roads or unpaved surfaces?
Yeah, we certainly have. They're actually built for that for sure. Thousands of systems, those are mostly truck mounted actually and rolling across the roads in the United States right now in almost every state at this point. That map is a little bit out of date. There also have been flown on C-17s, for example, overseas with no issue there. I'm not sure what the regulations are that we fall under for that, but I do know that we currently and actively have built for and do mobilize those via air and road, and especially over rugged conditions.
Hi, this is Sean. How does your system perform in polar conditions?
Hey, Sean. Good question. Any battery-based systems these days obviously needs to operate at an ideal temperature range, and that's going to be the same for anybody, especially if you're in kind of that sweet spot with the chemistries that are out there today, mostly lithium-ion-based systems. So there's a range there, but what we do is we actually have thermal management systems that are liquid heated and liquid cooled. But we also have heating systems as well built into our systems so that they can operate regardless of what the temperatures are outside, whether that's Arctic northern type of conditions, New York, or whether that's something in Las Vegas or over in the desert, let's say in the Middle East. We're able to maintain the proper temperature inside, both for safety and longevity of the system.
Thank you.
Thank you.
Do you have any other questions?
None from Sean.
I have no more questions. Thank you.
Thank you, Mr. Chong. Thank you, Sean.
Thanks. Justin, was there anything else you wanted to share with the time that we have left?
I tell you what, it's quite a mouthful to get through everything in 5 minutes. So I appreciate the challenge and the brief to try to make it as succinct as possible. Hopefully it is what you're looking for and suits one of your needs. I appreciate the time.
Thank you, Justin.
Thanks, Justin.
All right, well, we'll go ahead and give our judges a couple of minutes to deliberate and meet back with our next finalist. And next we'll hear from TM Energetics.
Hello, everyone. Thank you so much for the time and the opportunity to be able to pitch our idea. So the idea coming from TM Energetics, it's for NSIN Expeditionary Energy Challenge. And we are basically offering an innovative high-density energy storage solution for defense and commercial applications. In terms of the team for TM Energetics, I am Aydin Panahi, the CEO and founder of the TM Energetics, and I'm a research professor in chemical engineering in Worcester Polytechnic Institute. And I have a co-founder. She's basically running the business operation and management of the team. And we have two scientific advisors on the team. They are two mechanical engineering and chemical engineering professors from MIT and Worcester Polytechnic Institute. So to just introduce you our technology, our energy storage technology represents a significant advancement in the field of energy storage and power delivery systems. This innovative technology leverages the high energy density and cost effectiveness of metals to create a robust, scalable, and efficient energy storage solution. By utilizing metals, and particularly iron, an abundant and environmental friendly material, our technology offers a sustainable alternative to traditional battery systems. So in terms of the relevance to National Security Innovation Network, our technology is uniquely suited to meet the requirements by basically 15 SPSS, providing a reliable and high-performing power source for the ground electro-optical sensors uses space domain awareness. So to just give you a general idea of our solution, our technology burns metal to produce energy, and the byproducts of these basic burning metals are energy and metal oxide, and there is no carbon dioxide emissions. So the metal oxide will be recycled back to metal using hydrogen. And solar energy or solar panels are used to generate hydrogen needed for recycling metal oxide into metal. To give you a more detailed into the solution, our technology has two components which basically introduce air and metal into the our reactor. We get energy, we basically provide energy to a generator, and through some inverters, we can get whatever is needed for 15 SPSS telescope. And then the metal oxide, we are using an electrolyzer, generate hydrogen, and basically recycle back all of the metal oxide into metal. So our technology provides non-stop power of 25 kilowatt for 10 hours daily, and the technology requires around 200 kilograms of metal as a recyclable fuel. So we need solar panels to generate the energy needed for the electrolyzer, and the electrolyzer produces hydrogen for recycling metal fuels. We have a rotary generator capable of delivering 25 kilowatt continuous power and 15 kilowatt peak power. Power electronics plus Blue Eddy power inverter and a control panel designed by our company also is going to complement the technology. So based on the problem statement, I basically, our technology gives a final solution and a complete solution to what basically the 15 SPSS requires. Now, in terms of the consideration, our technology increasing the power density while reducing size, weight, and cost. We are offering an innovative aspects compared to existing solution, especially the battery and even the intermittent solar panel that creates issues time to time. And also, we have the feasibility in manufacturing and deployment. In terms of the implementation, we have reliable and accessible energy production. We have renewable fuel cycle. We have logistical ease because we can ship the metals easily to remote locations. And since it's a recyclable fuel, it's going to be just one-time shipment of fuel. We have a scalable output control, and we have high power capability. So in terms of the commercial viability, our current stage is basically we have incorporated the company, we have the ideas, and we are in the process of building the prototype and looking at the market potentials outside defense applications. There are a lot of applications in terms of grid storage, industrial power backup systems, electrical vehicle charging station, and residential energy storage. And thank you so much. That was my pitch. Any questions, any feedback, I can take it. Thank you.
Now over to our judges for questions.
Hi, Aiden, this is Richard Chong. Do you have any of these systems in production already or in operational use at this time?
Hi, Richard. So yes, we have at the lab scale, basically, the technology, but it's basically a small scale or bench scale technology.
Thank you.
Hi, this is Sean. How many solar panels are going to be required for this 200 kilogram, 200 kilograms of recyclable fuel system? And then related to that, what's the overall mass of that system that you're talking about that would require 200 kilograms of fuel? Over.
So in terms of the solar panel, it doesn't need more than 5 solar panels. And in terms of the mass, our system is just the whole thing. Looking at our designs, it's going to be less than probably 200 kilograms too. The whole system without the fuel mass.
Thank you.
Hi, this is Charles. Thanks for the presentation. So I just have a quick question on setting the system up. So for like deploying it out to a remote site, how long do you think it would take for the system to be set up and start operating?
So in terms of the pilot, we are anticipating that it's going to take us around 2 years to be able to have a pilot scale, 2 to 3 years.
Okay, I actually meant in terms of for like a operational system to go get deployed out to a site, how long it would take for it to be set up before the system starts providing power, like setting up the solar panels or doing any checkouts, how long that would take.
Yeah, so so the thing is, once you're burning the metals, so you are getting a continuous energy, right? And you can burn it continuously. Now, the metal oxide, it basically needs just an hour to be able to recycle it back to fuel. So during that 12 hours, so the 15 SPSS requires 12 hours continuous basically operation, and we are guaranteed that. But however, our technology can go up to 20 hours continuous run. Now, once basically there is no need for the power, we can use the solar panels to be able to recycle back all the metal oxides in an hour or so. So it doesn't take that long to be able to recycle back all of the oxides.
Okay, thank you.
Yeah. Thanks.
I didn't piggybacking on what Captain Trump was asking. I know you said it's going to take about 2 to 3 years to have your pilot program ready to go, but hypothetically speaking, once you did have a pilot, if I were to deploy it to a certain location, how long would it take for you to set up this system?
Just, I would say, probably a few months to set the whole thing. It's gonna be even maybe less than that. Honestly, I haven't calculated that. But the whole thing, it shouldn't take that long. So it's gonna be probably in the matters of a couple of weeks, I would say.
Thank you.
Yeah.
Do we have any other questions? Aiden, is there anything else you wanted to share with the remaining time?
No, thank you so much for the time and the opportunity to pitch our technology.
Thank you so much for being here.
Thank you, Aiden.
Thank you.
We'll begin our 2 minutes of deliberations. Our final presenter today is nanonuclear energy.
Hi, everyone. Thanks for coming to listen to this talk. I'd like to talk to you through one of the technologies we're working on at the moment and why we're excited about it, and how I hope to communicate to everybody about what we're doing so everyone's excited about it too. So as a bit of a background about what we're actually building, I'm going to be talking about the Odin microreactor, and what that specifically is an ISO container-sized portable nuclear reactor system that can be shipped anywhere in the world. And we wanted to build this because we saw a huge potential market where the diesel generators dominated in remote locations where there was no competition for them. So you can't just site wind and solar wherever you want, and hydro and geothermal aren't as available wherever you want it to. And for a lot of these locations as well, such as remote locations, remote habitation, remote projects, remote industry, mining projects, military bases, island communities, diesel generator reigned supreme without a challenge. But we saw a way that we could create a product that could be put into all of these areas that was zero carbon emitting, could operate for 20 years, and it would require very few personnel, and it would also remove the logistical challenges of bringing in diesel on a daily basis to power these things. And we brought on some of the best scientists in the world, we believe, and they got working on the Odin reactor. And so that's what we'd like to pitch a bit more about today. And to understand what we've done here, we used very historic, high TRL level components to assemble this. The low operating temperatures, low pressure systems, so that it wasn't creating a big load on top of the reactor with regard to operation, so it could have that 20-year lifetime lifespan, and consistently could outlay 1 to 1.5 megawatt electric power. And if you wanted it for industry, it can produce up to 5 megawatt thermal in a remote location, and the footprint is tiny. It really wouldn't take up more than that ISO container size. And the good part about this too is that because it can be put up on the back of a truck, you can move it by road, by rail, by ship, and you can get this thing anywhere in the world. And further to that, we believe that it'd be a very interesting prospect if companies were just buying the power and not having to buy the reactor. So we would just set up contracts where a company could buy us the power, and we would keep ownership, and we would operate it for them and sell it that way. And for most customers, they don't want to operate a reactor system or anything like that. And this would be a very appealing way of doing that, especially when you're looking at decarbonizing certain areas where there's no alternative other than diesel, such as big island communities where there are across the world hundreds of millions of people living in these areas where there's no solution. And this could offer a consistent high capacity factor solution to their power requirements. And what's really great about this is as we're building out this microreactor technology, and this is a very new and novel thing, the complexity of the reactor shrinks right down, so it becomes incredibly safe. So the mechanisms to failure become very few. In fact, with our passive safety system installed in the reactor, if every component was to break in the reactor, it would just passively radiate the heat out. So the accident scenarios you can see in big reactors in the past aren't possible with this. It's a naturally circulating system, so no pumps. And when you use that sort of thing, the mechanisms and the routes to failure are so much more reduced. And that's why you can have very few people on site, maybe 1 or 2 people that would actually have a very boring job just overseeing this thing, because it does not need a lot to operate. And the good part about this is it's going to be a plug-in and play system. We want to be able to take this reactor, ship it by road, by rail, and just put it in and plug into the local microgrid. So whereas a diesel generator might be operating in these locations already through a little microgrid, this would be the intention, is to put it down there. And if you needed more power, you could stack them. You could have 1 or 2 or 3, and you could put them, and you could scale up as you needed the power and scale back down again. And the advantage here is that you can mingle it with other energy solutions. This is a wonderful technology for integrating it with existing systems and providing more consistent power, because the consistency with nuclear is the highest of all things. And the great part about this is the wide range of applications. And I've mentioned a few already, and you can see a few up here, but there really is no limit to where you can put these things. And I think you could make a lot of areas not just cleaner, but richer too, by unlocking resources and human capital by having power there. So that's my presentation about the Odin microreactor. I hope this was interesting. Obviously, a lot more to say than in 5 minutes can fit in, but I think that we'll go with that for now. Thank you very much.
Right, let's turn it over to our judges for Q&A.
Hi, this is Sean. Thanks for the presentation. If I'm understanding correctly, the way you conceptualize this is retaining ownership of the reactor itself and placing next to the equipment that are needed to be powered, and then selling the power to whoever needs it. In a scenario where we are placing a small telescope on a remote island where there are no other users, what is the price per kilowatt hour in such a construct? Over.
So you are right. So when we were doing our examination of potential customers, it was by far the most popular model was to just sell the power and run it ourselves and then remove it and do all that sort of thing ourselves. So we knew that to be cost competitive, we had to beat remote diesel. So what we did was we began to look at case studies where there were remote communities operating on diesel. We spoke to governments in Philippines, Indonesia, and got an idea of island communities and the cost that they paid on the diesel, especially once you factor in the costs of the daily importation of that diesel to sustain those communities, as well as speaking to large mining manufacturers that run remote operations. Once we had an idea of what their expenditure was, we had to ensure that the reactor could obviously produce power over that contracted period of time, where it was obviously more economic than that diesel. So what I can say is that the price will almost certainly change. So I don't want to give a fixed price, but that we know the cost, the price of that remote diesel, and we know that we can very consistently beat that price no matter where that remote diesel is being shipped to. As an example, like one community we spoke to, a remote community up in Canada, they had 800 people there. Their diesel costs alone were $10 million for 10 people, for 800 people for 1 year. Now we would be operating that over a 20-year period. That's $200 million. We would be a fraction of that, maybe less than a quarter of that. So,
thank you.
Hi, this is Dick Chong. Do you have any of these capabilities already in production, and are they operationally in use at this time?
So we're building them now. We hope to be the first company in the world to do this. We're building the rigs and the prototypes right now so that they can go towards the licensing process with the regulators. But we're even speaking to countries abroad that once we build out the prototypes we're doing at the moment, we can deploy even sooner to these locations. So we're in the process of building out the first one. Hope to be the first one in the world, but it's over the next few years we'll be deploying these as commercial products, but nothing yet. So
thank you.
Further questions from the judges?
Nothing from me.
Nothing for myself either. I know we don't really control policy with this type of stuff at all, but it is really interesting to see. So thank you for presenting.
No problem at all. Glad this was interesting. So, thanks, everybody.
Thank you, James. All right. Moving along to wrap up today's event, I want to introduce you to Gloria Chu. She is part of NSIN's regional network team, and she's a regional engagement principal in the local area. Gloria, I turn it over to you.
Aloha, Mr. Dick Chong, the 15th SPSS team, the challenge pitch companies, and those who are watching. Thank you so much for being here with us today. We've had the pleasure of working with Mr. Dick Chong with the aim of seeking novel solutions for the 15th SPSS critical mission sets. And at the beginning, we've learned that acquiring power for a high power laser is a difficult undertaking. But we've just witnessed how to explore outside the boundaries of technical and policy requirements. I'm Gloria Chu, NSIN's Regional Engagement Principal, based out on Oahu, Hawaii. And NSIN is a program office within the Defense Innovation Unit, directly reporting to the Office of the Secretary of Defense. The strength of 15th SPSS is derived from it being the center of excellence for all ground-based optical space domain awareness in the U.S. Space Force. And driving this strength are the men and women of 15th SPSS, as well as the surrounding Maui community. Maui has grown into an international leader in space industry technology and accelerating innovation in missile tracking, space situational awareness, solar research, and data fusion. With Hawaii being the nexus between Asia Pacific and the continental United States, we are grateful for Mr. Dick Chung and the 15th SPSS to allow this unique opportunity for us to build a network of non-traditional problem solvers within the space domain. We encourage you to visit ensign.mil, as well as reach out to me, gchu.ctr@ensign.mil. That's gchoo.ctr@ensign.mil, as well as our Defense Innovation On-Ramp Hub Hawaii, Mr. Steve Brennan, the Managing Director, so that we can continue working together and accelerating these solutions for our warfighters. Thank you so much. And on to you, Angela.
Thank you, Gloria. And thanks again to everybody, our mission partner team, the On-Ramp Hub support, and to all of our participants who came and presented today. Super interesting, great to have you here. I know you put in a lot of time and effort, and we appreciate you. Before we conclude, I wanted to encourage everyone to, on the broadcast screen, to go ahead and check out the expo hall. You can meet the finalists there and read more about them and also engage with them through that expo hall. So I encourage you to go check it out. Otherwise, thank you all for viewing today, and I hope you enjoy the rest of your day.